Section 3.7, example 4, finding the inverses of toolkit functions. So identify which of the toolkit functions besides the quadratic function are not one-to-one and find a restricted domain on which each function is one-to-one, if any. So let's start off with the constant function. Oh, there we go. So the constant function here. So a constant function is just going to be our function at a specific point. Notice that the only way we could restrict this is if we only have one point, but that doesn't really make much sense. So we could come back here and say, no. So not one-to-one. So not one-to-one. And we cannot restrict. All right, let's test it out for identity. So get rid of this one. Let's take a look at identity. Now with the identity function, we are one-to-one. So not only do we pass a vertical line test, we also pass a horizontal line test. And because of that, we are one-to-one. So let's go ahead and tell them that we are one-to-one. So already one-to-one, no restriction needed. So 1-to-1, no restriction needed. Now for the absolute value functions. So absolute value function, I see that we could possibly be one-to-one, but we actually aren't one-to-one here at the moment. Let's see if we could restrict our domain. So x greater than 0. Ooh, I think we got it, greater than or equal to 0. All right, looks good. So we could either do x greater than or equal to 0, or we could even do less than or equal to 0. Either one. So let's state that. The absolute value. We could say not one-to-one. But for x being greater than or equal to 0, yes. And for x being less than or equal to 0, also yes. Let's shift these down. All right, they told us not to do quadratic, but let's just do it. Let's try quadratic functions. So quadratic function is our x squared function. It kind of looks like we could do something similar to what we did for the absolute value part. So notice that it changes directions here at our vertex. So our vertex, let's restrict it to, so x greater than or equal to 0. So greater than, you could literally just hit equal to sign. 0, okay, I like that, but we could also do the same thing for less than or equal to 0. Exact same thing. So we're changing the function from being a like not one-to-one function. Here we don't have any values. So here it looks like we have all of these values possible. Here, if we were to do a horizontal line test, you see that we would hit at these two spots here. Let's show for like x equals 2, or I'm sorry, y equals 2. Notice that at this line, we have two values. So this value here and also this value over here for that exact same spot. So here we cannot say that we are one-to-one. But just like we said earlier, if we were to restrict it, x greater than or equal to 0, then we have our function that we need. So over here, quadratic, we could say not one-to-one. So not one-to-one. but for x being greater than or equal to 0, we are 1-to-1, and for x being less than or equal to 0, we are also 1-to-1. Next, let's go for our cubic functions and see what we have. So cubic function, get rid of this one. Cubic function. Yep, it looks like we're 1-to-1 here. So 1-to-1 automatically. Next, let's try our square root function. Square root function, no matter how far we zoom out, it's always going to be the same thing. Yep, looks like it's 1-to-1 here. Already 1-to-1. Let's check for our cubed root function. Cubed root, same thing, we're 1-to-1 here. And lastly, for our reciprocal function. Reciprocal. Kind of looks like it might not be 1-to-1, but it is 1-to-1. I mean, if we were to try to do like a not a vertical line or not a horizontal line, it would intersect. But here we have our vertical lines here. So always on its own vertically, also horizontally. So yeah, this one's 1-to-1 as well. So this one too is 1-to-1. And there we go. So the only ones in question, let's take a look. So constant, got to get it out of here. We have our absolute value and our quadratic functions. Those are the only two that are not 1-to-1 naturally. But with those, we are able to restrict our domains to force it to be 1-to-1. There we go. If you have any questions, please feel free to ask. Otherwise, bye.